Hello, this is just a short video explaining how I did solve Mission023 from Gynvael EN channel. If you prefer reading, then feel free to read the blog post, but yeah, maybe you prefer watching, then I'm recording this short video explaining how this mission could be solved. So as usual, we have a mission status, which in this time informs us that one of our agents extracts some, what is it this time? Microfilm, but his computer got a victim of ransomware and it was encrypted. So we need to help and extract the flag. So what we got in this mission is actually two files. This is basically a console app 1 exe and a system image. The exe looks like a .NET application. Basically, this is like a default name for the console app if you create a .NET application. But yeah, actually we should check that. But my gut feeling was that it will be a .NET application. But anyway, I ran the Rabin2 tool to verify that, and actually we can also do that. With -e, we got some information about the console app. And if we scroll up a bit, we can see that it's basically the text that this is .NET version 4.0. So I started from that. I started looking into the exe, and I don't think there's a better tool than dnspy, so I used that. Loaded the binary into dnspy and inspected it a little bit. And the program is really short. Basically, there's not much going on. We have the helper program with encrypt data and encrypt text. And I poked around and saw that the encrypt data looks for the DB name DB, and if it finds it, it encrypts it and basically stores the ENC file with encrypted data. And what's important here is that it uses this reandel manage, and yeah, we set a key and set IV initialization vector. Vector is taken from this base 64 form, and the key is here. It's empty, so we could we should find out how it's being generated. And if we go to analyzed, we get the assigned by, it's assigned in main. And if we jump here, we see another function create key, which uses the text and some variable 32, and yeah, it's just use standard function that should be used for generating some bytes like securely. Okay, so how does this password is being generated? And the password is text, and text is Geronimo alpha plus generate password. And generate password is basically using some date time subtract. It subtracts the UTC now and date time, basically the 1970, so the epoch time. Okay, so our problem is that we don't know the UTC now when it was executed, but in the mission status, if we read it carefully, actually it says probably it's not important, but he has infected his computer last week. So we know more or less the time and date of the infection this week, not the last week, this week. And actually this is really important because we can somehow limit the time frame when this happened, so we don't have to like run infinite time. So having this information, what I did was actually create also a .NET application. I was thinking of creating a Python script, but basically why I use .NET is that I would get the same defaults as the program that was used to encrypt the database. So basically, yeah, I created the short .NET application that basically it's basically the same as the encryption. Instead of encryption, I use decrypt, create the cryptor, and use the same like values for the IV, and for the create key I just copy the function and modify it so it will use the provided date time. We don't know the date time, but I just created a loop, and yeah, from the first actual possible date till the date of the stream happens. So I assume it was yeah, encrypted before the actual stream aired. So we have the script, but actually we still don't have the file that was encrypted, and here where the second file comes in. So the second file of the package was this system.image, and it says disk image, and if we run the file on it, we got the information that this Linux revision 1.0 x4 file system. So we can actually mount it. And this is actually what I did. So I don't remember the command, but I will try to remember what I did. It was like mount -t x4. And yeah, if I don't remember, I'll just check the blog post, but it was, I think, -o loop. I actually have no idea what does it do, the parameters, apart from the -t, which specified the type of the image. It was, I think, system, and then the path where we want to mount it. So yeah, just standard password, which actually is not super secure. And let's see if it actually happened. Okay, so I remember correctly. So this is where we got the encrypted file. So we have it here. So we have the file, we have the script. Now we can run it. And actually, this is what I did. I ran the script over the night and got some results in the morning. Well, actually in the night was like 1 a.m. already. So it ran for a few hours and I got a lot of results. Actually, I got more than I expected because it was like, I don't know how many, too many files to actually check them manually. So what I did, I just, yeah, do the file. And also it was like almost all of them were data. But I just grabbed -VE, so inverted regex, so excluded all the data results and only, yeah, interested in those that were not data. And one of them were actually interesting, so it was SQLite 3.0 database. And actually, just one additional comment, actually the version I ran this script was actually broken, because I did not use write all bytes. I used something like write all text, and it got some strange Unicode characters in it. And basically, when I was running before this recording, I got some even stranger results in the actually decrypted files. But anyway, I did manage to find out that we have this SQLite database, and I got the, thankfully I saved the date time, so I got the actual timestamp, so I could rerun the script with the correct timestamp and got the write all bytes database file. Okay, so we know that this is the actual file that we are interested in. This is also the DB name DB. If we Google it, it will inform that this is some kind of database for Android device, standard file name. So it was also like give me idea that I will be looking for the database, not like MP mpg4 file. Okay, so we got the file, and now we need to somehow look into it. What I used for that, it was the SQL DB browser for SQLite, and actually, yeah, it managed to open the file, and there is only one table, data, and it has only two columns, ID and data. And here actually I got really lucky. I actually didn't know what to do next. I was just browsing through the data and just, I don't know, it sounds stupid, but like, I don't know, it caught my eye that this is basically random. Apart from this one looks less random than all the others. So yeah, I know, strange, but I just opened this and basically, yeah, there's like a clear indication that this is base 64. So what we can do with that is that just we can echo this. There's a lot of data, and we can paste it through base 64 minus D, I think minus, so it will read from the standard input, and just put it to decode PNG. Permission deny. Yeah, okay, because I'm in mount and we want to be in here. Okay, and we got some PNG. Let's hope it will correctly be displayed, and it is. Okay, so we have some Audacity audiogram or whatever it's called, but yeah, we see some wave file, how it would look like in Audacity. And my first idea was just to somehow put it in Audacity, because it's usually when you switch to spectrogram, you can see some like, yeah, nice letters that will read the flag, but it's basically difficult to do it from the image. So the next idea was that maybe it somehow encodes ASCII characters in here, but I quickly also dropped that idea because there was not too many items to actually convert to ASCII. So the third idea was that, well, maybe it's a Morse code. And so yeah, what I did was actually Google for Morse code. I don't remember it by heart, so Morse code. Okay, it's in Polish, but let's, the second link was actually in English. So let's just open this one. And I had this one, like, it's like, how do you make it smaller? It's just, not used to this Ubuntu. Okay, so I have this one on one side and the other image on the other, and just try to, okay, so this one looks like a dash. It's just a long peak. So what it could be, it's T. Okay, then we have 4 dots, and this is H. And then we have 2 dots, and 2 dots could be 2 dots. Where do we have 2 dots? We have I. Okay, so this sounds like something that actually might be encoded as this, because 3 dots, of course, is S, because this is probably one of the 2 I know by heart, Morse code. So yeah, this is basically a Morse code. So at first I thought maybe it could be somehow automatically translated, but there was not too many items on this image, so I just did it manually. And when you do this, you actually get the flag, and the flag is somewhere here. And yeah, this is Romeo Charlie Shall We Dance, which is from Apocalypse Now movie, and this is actually the flag. So that's all. This was really a nice mission. I think I spent around 4 hours solving this. So 3 hours, it was like after the stream ended till 1 AM. So it was like 3 hours from 10 p.m. till 1 a.m. and then just 1 hour in the morning after I got the SQLDB database. So nice mission. Thanks Foxtrot Charlie and Gynvael for having the mission, and I hope you enjoy it. If so, then leave me a comment and subscribe to the channel.